Hello and welcome to this video. My name is David Thorne. This is now the 16th video of my C programming tutorial playlist. And this is kind of another side note before we move on to the likes of binary and signed and unsigned integers and so on, because we need to have a little bit of an understanding of the powers and the log as well. The power, yeah. Anyway, let's just get straight into this, shall we? As you can see here, we have 2 to the power of 0. All right. When we run this, we've got power, the math function, or in the math header here, you've got the power function, and we're just saying 2 to the power of 0. And as you can see here, we get 1. Okay, so 2 to the power of 0 is nothing more than basically us saying 1 is because we're not timesing the 2 by anything. We're literally, it's just 1. And then saying that 2 to the power of 1 is basically timesing itself by itself once, which is then just going to be 1 times 2. So, and now we're saying 2 to the power of 2 is then 1 times 2 times 2. And then we can keep going, and this is then 1 times 2 times 2 times 2, 3 times. And let's just copy and paste this once again. Whoops. Let's just copy and paste this once again. And this is then, let's just clean that up. This is then 1 times 2 times 2 times 2 times 2. There's 4 times. And we'll paste it again. And this is then the same story here. And we're making a nice little kind of like half pyramid here. If you know the name of that, put it in the comments below. And then the final one is here. So 2 to the power of 7 is 2 times 2 is done 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, and all times by 1. Okay. And that goes down to 6 of them, 5 of them, 4 of them, 3, 2, 1. And then obviously 2 to the power of 0, right? It doesn't times it by itself at any point here. Now this is super interesting to understand why we need to understand this, all right? Because when we start talking about binary and we start talking about bits and bytes and 2's complement and so on, and how to have negative number signed, unsigned, and so on, we need to really have a good grasp of this, and understanding at least to 2 to the power of 7 is kind of worthwhile understanding. Now, if you want to go in reverse, all right, the C library does have another way of doing this, but we're going to do it the traditional way, all right, and just make it that little bit more complex. And we're going to say log, and then by default a log is going to be by 10, all right, but we want it by 2. Well, we can do a little bit of logarithmic arithmetic here, and we can convert it, all right. So we've got then log 128, which is then the output of 2 to the power of 7, divided by the base, that what it was 2 to the power, right, here. And then we're just going through all of them here, and we scroll down, or we execute the code once again, and you'll see here that we get the exact reverse. So log of 128 is then 7. Obviously, we're just pumping that out a float here instead. And then 64, 32, 16, 8, 4, 2, 1, and so on. And we get is then 0, and so on. All right. So this is nothing new whatsoever. So this is basically the reverses on it. So if you're ever unsure about how this is done, but you don't want to do any programming first of all, then what I suggest, and I'll just open Desmos now. Yeah, so what I suggest is using Desmos, because this is really quite good to understand how to do 2 to the powers, basically. So you've got 2 to the power of 1, and then 2 to the power of 2, and so on. And we can add like variables on this. So we want then the base to be 2, and then the we're just going to call it the I don't want to call it E, and we can call it Z. Or if we call A as the base and B as the actual exponent itself, and we're going to say 1, and we'll say that this can go all the way through to 7 and step by 1, and then we say A to the power of B, all right? And you can see here we can put this to 0, and A to the power of B, as in 0 at the moment, is then 1. A to the power of 1 is then 2. A to the power of 2 is then 4. a to the power of 3 is then 8, a to the power of 4 is then 16, a to the power of 5 is 32, a to the power of 6 is then 64, and a to the power of 7 is then 128. And if we just move this to be 8, and now we'll be able to see that 2 to the power of 8 is 256. Now what's super important for this is that we say that it's a to the power of b minus 1, all right, because we need this because of the programming, all right. So when we come back to here, we get 1, get 2, 3, 4, 5. Oh, we know that it's the total value that it can store, all right, but it's going to come into effect later on, but the total amount of a number that can be stored of a to the power, or 2 to the power of 7, all right, or a to the power of b, is going to be 255. Even though if we put this is 8 bits, all right, it's going to say 256, but we can't do it like that. We have to minus 1, but that's going to come in other video tutorials as well. But I just wanted to let you know that if you're going to do C programming, and you're just going to be doing pure number related stuff, then I would highly suggest doing it in Desmos first, okay? And this is not C, this is just basically normal algebra and so on. And do it in algebra, make sure you understand it and change the numbers and draw a graph and stuff and see what it looks like first. And here, test it here, and you can save your work here. And once you're 100% certain that the mathematics are correct, then you can come and change all of your variable names and your values and put them back into your C code, all right? Because you don't want to be compiling stuff all the time just to do some basic mathematics, and you don't want to get your calculator out, and you want to save your work. So this is just a word of advice if you're going to start doing any mathematics and to remove any bugs that you want, all right? Anyway, so we now understand 2 to the power rule, okay? And it's going to be completely important in all of the other videos that we do for you to fully understand binary, for you to fully debug memory and so on, and hexadecimal and stuff like that. So it's just a real fundamental that you need to understand, all right? And in addition to this, if you are interested in enhancing your mathematical skills and so on, then I would really highly suggest going over to Khan Academy and basically starting to do the integrated maths level 1 or 1 course first of all, and then doing 2 and 3 and stuff like that. It's super awesome. And it has all different videos and stuff like that, how to do it. But if you're going to have problems with algebra, or you're going to have problems with mathematics, but you want to learn about C, and you want to do like close to, you're going to have a slight problem. So I would also advise investing your time in doing integrated maths and so on, because it kind of mirrors computing as well. Anyway, with that said, thank you very much for watching, and I'll see you in the next video. Ciao, ciao. Goodbye.